Hi, 8th grade. We are on lesson 4, session 2, understanding dilations and similarity. So let's look at number 1. Figure S is a dilation from figure T. The scale factor is 1.5. Okay, remember what I said last lesson? If it's greater than 1, that means our things are getting bigger. If it's less than 1, that means our shapes are getting smaller, okay? So we know that our shape is getting bigger. The center of dilation is point A. How are figures S and T the same? Well, we know that they are the same because they both are the same shape. And their angle measurements are the same. How are they different? Well, they're different because T is larger than S. Okay, figures that are the same shape are similar. Two figures that are similar, you can map one onto the other by a sequence of 1 or 2 transformations. So figure T and S in problem 1 are similar because we could map figure S onto figure T using a dilation. Similar looks like this. Congruent meant that they were exactly the same shape, same size. Similar means, oh yeah, that's the same shape, but let's do something to it so that it's exactly the same. Okay, so similar is what that means. Is T similar to S? How do you know? Yes, it is the same shape, just dilated. Number 3, choose two figures below that appear to be similar and write a similarity statement for them. All right, already I can tell A and D are the same shape, one just dilated from the other. So could I say D is a dilation of A? In other words, D got bigger and made A. B and C are nothing. Okay. Number 1, figure DEFGHI, that's a big name for such a figure, is similar to DEFGHI prime. The scale factor is a third. Remember, if things are less than 1, it's going to shrink. And the center of dilation is point X. Okay. Side DE, which is right here, side DE corresponds to side DE up here. The quotient of their lengths can be written as DE prime over DE is the same as 4 over 12. Basically, could I take this one right here and make it's 4, and this guy up here is 12 long? Could I say 4 over 12? I don't know why they want to put 4 over 12. I'd put 12 over 4, but that's just me. But I guess 4 over 12 is the same as 1/3, right? So that's how you could find the scale factor, is by taking the copy or the image and dividing it by the original. Now go find the fractions for the rest of the 5 corresponding side lengths. All right, so EF is 2. And then EF over here is 1, 2, 3, 4, 5, 6. So 2/6, which makes sense because isn't 2/6 the same as 1/3, which it should be. That's the scale factor. I'm gonna let you guys finish these on your own, okay? Go through, just count the side lengths and then make them into a fraction, okay? You put the original, or actually put the copy, put the image over the original, okay? So small number goes on top, big number goes on bottom. You guys can finish those ones. Basically, what is the relationship between all of their quotients of their side lengths? What is the scale factor? Everything should be a third, okay? I should be able to take the prime divided by the original, and get a third. That is the scale factor. How do measures of the angles compare? The angles are congruent, okay? Corresponding angles are the same. They don't change. What is the relationship between corresponding side lengths and corresponding angles in similar figures? DEFGI and DEFGI prime. Basically, everything is proportional, right? So side lengths are proportional, and angles are congruent. In other words, they're the exact same. Number 3, describe 2 ways you could tell that 2 figures are similar. Well, we can look at their angles. If their angles are the same, they are similar. And shape, look at the whole shape, see if the whole shape is the same shape. And then you can also find the scale factor. How do you find the scale factor? You take one side and you divide it by the other side. And if you can take that and then do all their corresponding sides like that, then you know it's congruent, okay? Or you know that it's similar. Label the center of dilation for triangles XYZ and XYZ prime. Then write a similarity statement for the triangles. Okay, can I show you guys how you would find the center of dilation? Remember how the center of dilation can go through all the points perfectly in a straight line? Well, if I want to go through this point and this point, I already have that straight line, right? And if I want to go through this point and this point, I already have that straight line. So where do all my lines end up exactly? At X. So that means that the center of dilation is X. Okay? And write a similarity statement. So that means X, Y, Z triangle is similar to triangle X, Y, Z prime. Alright. Alright guys, page 89 and 90 are what we're going to do in class. Please scan 88 and submit it. I should see everything in here, especially this part right here that I didn't do with you. I'm looking for that specifically to be filled out, okay? Alright guys, I'll see you later.